Hello there, Nareg is here. Today we're gonna talk about sets. So what is a set actually? It's a collection of elements or objects. So whenever you have a certain collection of objects, you're gonna call it the whole collection as a set. Now each object is known to be an element of this set. So let's take a small example. What about the 26 letters of the alphabet? So these 26 letters, they represent a certain set, and each letter is an element of this set. Now, how do we note a certain set? So let's talk about the set notation. Of course, I'm gonna take the case of the set of digits. Let's say we're talking about the set of digits. You can write it down as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what it's called the roster notation. So this is the roster notation, or a notation or extension. We're using the notation by extension. In roster notation or notation by extension, each element should appear in your set, and of course there's no need to repeat a certain element. Plus there's also one more important thing, that the order is not important. Instead of saying 0, 1, 2, 3, in case I started with 2, 0, 1, 3, etc., so it will remain the same set. The order does not change the set. All right. What is the second way of expressing this same set, the set of digits? I can write it down as x, which is a certain variable, such that x is a whole number. So I'm going to say it's a whole number. And x is smaller than 10. So whenever I'm writing down in this way, this is a set builder notation. So in this case, it's a set builder notation, or it's a notation by comprehension. So I'm trying to explain about my set. It is formed by which elements, by giving a certain explanation. All right. So when we're talking about elements and sets, in this case we need to talk about a certain characteristic, that is an element belonging to a set or does not belong. For example, the set of digits, and I'm gonna, let's say, take the element 8. The element 8, is it does it belong to the set of these digits? Of course. So you have to write down 8 belongs to this set. Let's say this set was named E, so you write it down, E, 8 belongs to E. Now what about the element, let's say 11? 11 is not an element of this set E, so you will have to say does not belong, and you have to use this symbol in order to say 11 does not belong to E. So what about the element 0, for example? 0, it does belong to E. So whenever you're talking about a certain element belonging or not belonging, you use this symbol. Later we're gonna see that there is also, instead of element, we have subsets, and in that case we cannot say a subset belongs to a set. We have to use is contained or is included. We're gonna see that later. So this was the first idea about sets. The second thing that we should know about sets is equality. So one of the most important characteristics is equality of sets. In this case, let's say we have two sets, E and F. Each element of E is an element of F. So in this case, we're gonna have E equal to F. So what about taking an example? E is equal to 0, 1, 2, and F is equal to 2, 0, 1. As you can see, the elements of E are the same elements of the set F. So in this case, I can deduce that E is equal to F. I have two equal sets. All right. What about the empty set? So, what about the empty set? Whenever we're going to talk about empty set, it means that it's a certain set E, let's call it E, which has no elements. So it is formed by no elements. It is symbolized by phi. So E is equal to the empty set. Let's take an example. In case you were asked to solve x squared plus 1 is equal to 0, and the roots of this equation are the elements of the set E. So whenever you're gonna try to solve this equation, you're gonna say x squared is different than minus 1. So this equation has no real roots. So the set E will have no elements. It will be the empty set. All right. What about the set which is called singleton? In this case, it is a set formed by one element. So in this case, it is formed by one single element. Let's say this element is A. All right. So I'm going to take an example. Let's say we're going to solve this equation, x plus 1 is equal to 0, and the roots of this equation are actually the elements of the set E. So you simply solve x is equal to minus 1. You're going to have E, which is formed by the element minus 1. It is formed by one element, so it's a singleton. What about the set which is called a pair? So whenever we have a pair, in this case, your set E is formed by two elements. It is formed by A and another element B. All right. I'm going to take an example again related to this part. What about solving the equation x squared minus 1 is equal to 0? So the solution or the roots of this equation will form the elements of the set E. So you simply say it's x minus 1 times x plus 1, which is equal to 0. So you will have x is equal to 1 or x is equal to minus 1. So your set E is formed by two elements, minus 1 and 1. It is formed by two elements, so we can call this set as a pair. Alright, the last part of this video will be about the definition of a subset subset of a set. So what do we mean by subset? Whenever we have, I'm gonna introduce you about the representation of a certain set. Let's say we had E, which is formed by the numbers 1, 2, 3, 4, 5, and 6. These numbers are the numbers found on the dice. So this is the whole set of numbers on the dice. And then I ask you to choose the set A, such as A represents the numbers which are even. So you will have to say A is formed by the elements 2, 4, and 6. Now, as you can see, A is a part of E. A is a part of E. So from this, I can simply denote that A is contained in E. A is included in E. But I cannot say E is included in A. Whenever the elements of A are the elements found in E, so you can say that A is a part of E or A is contained in E. Now, how do I represent this? Very simple. This is E. This is E, the set E. It is formed by 1, 2, 3, 4, 5, and 6. And this is the set A, which is 2, 4, 6. As you can see, the set A is a part of set E. That's why I can say A is contained in E. Now, what about, let's say, we have another subset, which is B, formed by 1, 3, and 7. And 7 is a number found outside, of course, the set E. You will have to say that this is your set B. This is your set B. B is not included, is not contained in E. So you simply say does not include in E. So this is how you denote about a relation between a subset and a set. Subset is a part of a larger set. In this case, A is a subset of E. B, it is a set, but it is not a subset of E. Some part of it, yes, but it has the number 7, which is not included in E. Alright, that's all for this video. I hope it was helpful, and why don't you subscribe to my channel? In that case, you'll be notified whenever I upload new material. And of course, I can share with you my Instagram and Facebook account. That's all for this time. See you later.